Good morning, everyone. Electricity plays a very important role in our life because electricity provides us easier way of life. Hence, in this lesson, we'll be discussing about electric charges. When you talk about electric charges, this latter means the electric interaction and magnetic interaction between subatomic particles and other charged particles. We have to recall that atom is actually the building block of matter, which is composed of three subatomic particles, proton, neutron, and electron. So the charges is actually governed by the law of charges with their behavior. This says that like charges repel each other and unlike charges attract each other. For example, positive charge that is actually put close to a negative charge is attracted, while a positive and a positive charge put close to one another will repel, just like the two negative charges. So atom which has an equal number of protons and electrons is actually called electrically neutral atom, while atoms with imbalanced number of protons and electrons is what we call ion. So ion which have more protons than electrons are called cations or known as the positive ions, while atoms with more electrons than protons is what we call anions, and that is also known as the negative ions. There are actually three different methods of charging. One is charging by rubbing. If you have a pen and if you want to observe charging by rubbing, is you can rub it to your hair, and then that rub pen, you put it close to a small piece of paper. You observe, or you can observe that the small piece of paper will be attracted to the pen. Next is charging by conduction. Charging a neutral object by conduction actually would, for example, a metal sphere with an excess of negative charge is brought near to a neutral electroscope. Then upon the contact of electron, this will move from the sphere to the electroscope and will spread about uniformly. And then the metal sphere now has a less excess negative charge. The metal sphere becomes now negative charge using conduction. Another one is the charging by induction. For example, two balloons here, A and B, is neutral. If a negatively charged balloon is put close to this neutral balloons, the tendency is that the positive charge will move towards the negative balloon, and the negative charges will now repel and will move to the balloon B. Hence, the balloon will now become positive charges in A, and the balloon B will now be negatively charged balloon. Electric force and electric field is explained by Coulomb's law, where electric force between two charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. In formula, we can write that as force of electric charge is equal to the proportionally constant K multiplied by the product of the two charges divided by the square of the distance between the charges. You have to remember the constant K is always equal to 8.99 times 10 to the power of 9 Newton meter squared per Coulomb squared. And our Q1 is your first charge, and Q2 is your second charge, and R is the distance or the separation distance between the two charges. If there is several charges present, the total force acting on a body on a given charge is equal to the vector sum of forces exerted it by all the other forces. So you just add the total forces of those different charges to one another. For example, the force on charge 1 exerted by charge 2, you get that using the Coulomb's law, this one. And then you get another force on another charge, and to get the total force of that, you just sum it up. For example, the electron with a charge of 1.60 times 10 to the negative 19 Coulomb and proton with 1.60 times 10 to the negative 19 coulomb of a hydrogen atom are separated by a distance of approximately 5.3 times 10 to the power of 11 meters. Find the magnitude of the electric forces. How are we going to do that?
Given is of electron is equal to 1.60 times 10 to the negative 19 coulomb, and charge of proton is equal to 1.60 times 10 to the negative 19 coulomb, and our separation distance is equal to 5.3 times 10 to the negative 11 meters. And we have to recall that our K is equal to 8.99 times 10 to the 9 Newton meters squared per coulomb squared. So how are we going to do that? Let's use our Coulomb's law. Force is equal to proportionally constant times charge 1 and charge 2 over the distance between them squared. Hence, substitute the values. F is equal to 8.99 times 10 to the power of 9 Newton meters squared per coulomb squared. You multiply the two charges, 1.60 times 10 to the power of negative 19 coulomb times 1.60 times 10 to the negative 19 coulomb over the separation between them is 5.3, this one. So 5.3 times 10 to the negative 19 meters quantity squared. So if you will manipulate that using a calculator, you will get that force is equal to 8.2 times 10 to the power of 8 Newton. And this is the force, final force.
Another example for superposition principle, consider 3-point charges located at the corners of the right triangle as shown in figure, and where charge 1 is actually equal to charge 3, which is equal to 5 times 10 to the negative 6 coulomb, and charge 2 is equal to 2.0 times 10 to the negative 6 coulomb, and our A is equal to 0.10 meters, or A is actually the separation distance between them. So find the resultant force.
Okay, so we are going to find what is the resultant force exerted by these three charges illustrated in this diagram. So how are you going to get the charge or the force, resultant force, by charge 1 onto 3 if we don't know this value? So to get that, let's recall Pythagorean Theorem, which tells us that a squared plus b squared is equal to c squared. So the value of this one is also equal to a, so that is 0.10 meters squared plus 0.10 meters squared is equal to c squared. Manipulating this one with your calculator, you will know that c is equal to 0.14. So 0.14 is the distance from charge 1 to charge 3. So this is equal to 0.14. This is R. Let's say this is R. So let's get force of charge 1 onto 3. K times charge 1, charge 3 over the separation distance between them. So you'll have 8.99 times 10 to the 9 Newton meters squared per coulomb squared times charge 1 is equal to, we know that charge 1 is equal to, from the given, let's record first, charge 1 is equal to 5 times 10 to the negative 6 coulomb, and charge 3 is equal to 5 point, and we know that charge 1 is also equal to charge 3, and charge 2 is equal to 2.0 times 10 to the power of negative 6 coulomb. So you just substitute the value of charge 1, and that is 5 times 10 to the power of negative 6 coulomb times 5 times 10 to the negative 6 coulomb over the separation distance is 0.14 meters quantity squared. So you multiply 8.99 times 10 to the power of 9 Newton meters squared per coulomb squared. You multiply this one and you will get 2.5 times 10 to the negative 11 coulomb squared divided by 0.14 meters quantity squared. And if you will use your calculator manipulating this one, charge 1 onto 3, you will get 11.46 Newton. So at this point, you will get, or let's get the force of charge 2 onto 3. So using the equation again, charge 3 over resultant squared is equal to 8.99 times 10 to the power of 9 Newton meters squared per coulomb squared. Just substitute the value of charge 2, that is 2 times 10 to the power of negative 6 coulomb times 5 times 10 to the negative 6 coulomb over the resultant, or the distance between them, is equal to 0.10 meters quantity squared. So 8.99 times 10 to the 9 Newton meters squared per coulomb squared. You multiply this 2 and you will get 1.0 times 10 to the negative 11 coulomb squared over 0.10 squared is 0.01 meters quantity squared. So this is equal to 1, this is equal to 1. Using your calculator, you will get that force of charge 2 on 3 is equal to 9.0 Newton. Hence, our resultant force at charge 3 is equal to force onto 1 on 3 plus force of charge 2 onto 3, and that is equal to, substituting the values, force 1 onto 3 is 11.46 Newton plus force on 2 on 3 is 9.0 Newton, and you will get 20.46 Newton. And this is our resultant force.
Okay, that's how you are going to solve for the charges or the force, electric force of the different charges, considering the distance between them. Now let's proceed to electric field lines. When you talk about electric field lines, the density or thickness of these lines is directly proportional to the strength of the electric field at any region in space. You have to remember that. So in the field lines are close to each other and the electric field is stronger. If the field lines are actually not or far from each other, the electric field is weaker, just like this one. Okay, if you look at the positive charge, the electric field lines are outward, while the negative charge are going inward. So if two charges are put close to one another, the tendency is that they will be attracted because the positive charge is outward, going outward, and the negative charge is going inward. So the region of space around an electrically charged body can be identified using this formula. Electric field is equal to force over the charge, or electric field is equal to proportionally constant K times the charge over our distance between them square. To detect the presence of electric field at a particular region, another charge body is usually test charge Q is actually placed, And if the test charge experiences a force of electrical origin, then an electric field is present at the region. For example, a charge 1 that is equal to 7 microcoulomb is at the origin, and a charge 2 is equal to negative 5 microcoulomb is on the x-axis, that is 0.300 meters from the origin, is at the right. So find the electric field strength at point P, which is on the y-axis 0.40 meters from the origin. This is how we are going to solve that.
Okay, we know that charge 1 is equal to 7.0 microcoulomb, or that is equal to 7 times 10 to the negative 6 coulomb. And our charge 2 is equal to negative 5.00 microcoulomb, or that is equal to 5.0 negative 5 times 10 to the negative 6 coulomb. So because we are to get the electric field at point P that is found in y, that is equal to 0.400 meters. To be easier, let's plot this charges in a Cartesian plane. We know that charge 1 is actually found at the origin, and our charge 2 is found in the x-axis, that is equal to 0.300 meters, and our charge E is found in y, that is equal to 0.400 meters. Okay, to get the distance from the charge 2 onto the charge Q, we know that this distance is equal to 0.300 meters and this distance is equal to 0.400 meters. We are to get this one. So we can use the Pythagorean Theorem. A squared plus b squared is equal to c squared. A squared is equal to 0.300 meters, that is squared, plus our b is 0.400 meters squared, that is equal to c squared. So manipulating this one using your calculator, you will have c squared is equal to 0.25 meters squared, so c is equal to 0.5 meters. By this, we know that the distance from E to charge 2 is equal to 0.5 meters. So the magnitude of the electric field produced by charge 2 is equal to force. 2 is equal to proportionally constant times the charge 2 over the distance between the charge 2 to the charge E at 0.400 meters. So just substitute the value again, 8.99 times 10 Newton meters times 10 to the power of 9 Newton meters squared per coulomb squared. You multiply it with the value of our charge 2, which is equal to 7. Charge 2 is equal to that 7 times 10 to the negative 6 coulomb over the distance between them is equal to 0.400 meters quantity squared, and manipulating that one using our calculator, you will get 3.93 times 10 to the power of 5 Newton per coulomb. Okay, so the magnitude of force or charge 1 onto charge E can be calculated using this one. You multiply the proportional constant times the value of your charge 1 times the distance between the charge 1 and the point, the electric field E. So you just substitute the values. 5 times 10 to the negative 6 coulomb over the distance between them is 0.500 meters. This is squared, and you multiply it with the value of our constant K, 8.99 times 10 to the power of 9 Newton meter squared per coulomb squared, and using our calculator you will get that force 1 is actually equal to 1.80 times 10 to the 5 newton